Hello everyone. In today's lecture, we are going to derive an expression for acceptance angle. We will try to understand the concept of acceptance cone and a parameter which is very important related to optical fibers known as numerical aperture. It means we will discuss acceptance angle, acceptance cone and numerical aperture. So what we have here, we have an optical fiber. So this one is the core of that optical fiber, which is surrounded by another layer of glass or plastic known as cladding. This core is having a refractive index mu1 and cladding is having a refractive index mu2. Now there is a medium from where the signal is launched into the optical fiber. Means there is a medium from where the information will enter into the optical fiber. Let mu0 is the refractive index of that medium from where the light is launched, and generally that launching medium is air from where the light is or from where the signal will enter into the optical fiber. This core is having refractive index mu1 which is greater than the refractive index of cladding. Only then the total internal reflection can take place. So this acceptance angle is basically the angle made by the incident ray. This is the ray which will enter from launching medium into the optical fiber. So the acceptance angle is the external angle made by incident ray with the fiber axis for which the angle of incidence is equal to critical angle. Again I am repeating, the acceptance angle is that external angle for which the angle of incidence over the core cladding interface is critical angle. As we know, in case of an optical fiber, only those light rays will be accepted by the optical fiber. Only those light rays, they can travel from transmitter to receiver for which angle of incidence is greater than critical angle, either equal to or greater than critical angle. It means all those light rays will be accepted for which angle of incidence is either equal to critical angle or greater than critical angle. So this external angle, for this angle, here the angle of incidence will be critical angle and the angle of refraction will be 90 degree. If this angle, this external angle is having any other value less than this acceptance angle, then for all those light rays, at this point, angle of incidence will be greater than critical angle. I am repeating it. For all the light rays, for which angle of incidence which is made with this fiber axis is less than this acceptance angle, then all those light rays, they will strike over this core cladding interface at an angle greater than critical angle. So it is the maximum external angle which is accepted by this optical fiber. That maximum external angle for which this light ray will strike at an angle equal to critical angle, or in simple words, acceptance angle is the external angle made by the light with fiber axis for which I is equal to IC. Since the light rays, only those light rays will be accepted for which angle of incidence is equal to or greater than critical angle. So all those light rays which will enter into this optical fiber at an angle equal to this acceptance angle or at an angle less than this acceptance angle, all such type of light rays, they will be accepted by this optical fiber, because all such type of light rays, they will suffer total internal reflection, because all such type of light rays, they will make an angle greater than critical angle, and for acceptance angle, the light ray will make an angle at this point equal to critical angle. So that is the reason that angle is known as acceptance angle. So I'm repeating it. The external angle of incidence made by a ray with fiber axis corresponding to critical angle of incidence at core cladding boundary is known as acceptance angle. So this acceptance angle, that depends upon the critical angle of an optical fiber. Now we are going to derive an expression for acceptance angle using Snell's law. So we are having three different mediums here. The first one from where the light is launched, second one is core, and the third one is cladding. Now I have just forgotten to mention this acceptance cone. So we can understand this acceptance cone from here. This particular ray, this ray that corresponds to acceptance angle. If this angle is acceptance angle, then this angle I is IC. If this theta E is acceptance angle, then I is IC here and R will be 90. If you will rotate this light ray, this particular light ray, which corresponds to acceptance angle about this fiber axis, means you have to rotate this ray about this fiber axis. So when you will rotate this light ray which corresponds to acceptance angle about the fiber axis, you are going to get a cone. So when you are rotating it, you are getting this cone, and all these light rays which are entering through this cone, all these light rays, they will make an angle over this core cladding interface equal to, greater than critical angle. Means all these light rays which will enter through this cone, these light rays will be accepted by the optical fiber. That is the reason this cone is known as acceptance cone. Since for all these light rays, the angle of incidence over this point will be greater than critical angle, that is why those light rays will be accepted by this optical fiber. That is why this cone is known as acceptance cone. So now we will derive this relationship for acceptance angle. For this, first we will apply this Snell's law for launching medium and core. So light is entering from this launching medium into this core. Then according to Snell's law, mu naught sine theta E, mu naught is the refractive index of launching medium, mu naught sine theta E will be equal to mu 1 sine theta. Then we will apply this Snell's law for core and cladding. So this mu 1 sine I, that will be equal to mu 2 sine R. And if you will see this triangle ABC, then this is theta and this one is I. So theta plus I is 90 degree. Clear? If this theta E, if this external angle is equal to acceptance angle, then I will be IC. When theta E will be alpha, acceptance angle, I will be IC, and when I is critical angle, then R will be 90. Now we are going to use this condition in equation number 1 and 2. So first we are going to take equation number 1. Mu naught sine theta E is mu 1 sine theta. Instead of theta, we will write 90 minus I here. You are getting mu 1 cos I. Then theta E is alpha. So if you will substitute theta E alpha here, then I will be IC. So you are getting mu naught sine alpha is equal to mu 1 cos IC. It means that sine alpha is mu 1 upon mu naught cos IC. Now we'll find the value of this cos IC using your equation number 2. So in equation number 2, if you will substitute I as IC, you will get mu 1 sine IC. And if you will substitute IC, then R is automatically 90. So mu 1 sine IC is mu 2. So sine IC is mu 2 upon mu 1. So cos IC, that will be equal to this. So it will be under root 1 minus mu 2 square upon mu 1 square. Now substitute in equation this value in equation number 3. You are getting sine alpha equal to this. So acceptance angle is equal to sine inverse of under root mu 1 square minus mu 2 square upon mu naught. And this mu naught, that is the refractive index of launching medium, and generally the launching medium is air. So if the launching medium is air, then this mu naught is having one value. So acceptance angle is sine inverse of under root mu 1 square minus mu 2 square, where mu 1 is the refractive index of core and mu 2 is the refractive index of cladding. So I am just concluding this. Acceptance angle is that external angle made by the incident ray with the fiber axis for which angle of incidence is critical angle, and acceptance cone that is obtained when you will rotate this light ray which corresponds to acceptance angle about the fiber axis. Then you are going to get a cone, and all the light rays which are entering through that cone, all those light rays will be accepted by the optical fiber. Reason is, all those light rays which will enter through this acceptance cone, for all those light rays I will be greater than IC here. So if I is greater than IC, then total internal reflection will take place there. So this is acceptance angle and this one is acceptance cone. And the third one is numerical aperture. So basically, sine of acceptance angle is known as numerical aperture. Alpha is acceptance angle and sine of alpha is known as numerical aperture. Now we will discuss this numerical aperture in detail in next lecture. So this is your acceptance angle and acceptance cone. Thank you.